Good morning, all of you. I'm Hardik Shah, your engineering drawing tutor. Now, let us discuss today about some engineering curves which are used in industry to draw different types of engineering drawings. So, in that, first of all, we'll see ellipse. Ellipse is a curve whose major and minor axis dimensions are different. Ellipse is like a circle, but in circle, major and minor axis diameter or radii are same, whereas in ellipse, major and minor axis dimensions are different. So that is called an ellipse. So first of all, let us see ellipse by concentric circle method. There are different methods to draw ellipse. In that, first method is concentric circle method. Now, major axis dimension of ellipse is 100 mm and minor axis dimension is 70 mm. So we have to draw concentric circles of diameters 100 mm and 70 mm. It means that we have to draw circles with radii 50 mm and 35 mm. So draw two circles which have same center but different radii. After drawing that, we have to draw one axis, means line segment AB and line segment CD perpendicular to it. So whose dimensions are AB is of 100 mm and CD is of 70 mm. Now extend C and D point up to bigger circle, and then we have to divide a circle into 12 different parts or 12 equal parts. So how can we draw or divide circle in 12 equal parts? So take a protector, put it on line segment AB, and then mark it on 30 degree, 60 degree, 90 degree, 120 degree and 150 degree, and join them with a center. So we can get this type of drawing. So here we divided a circle in 12 equal parts. Now name them 1 to 12 or 1 to 10, inner and outer circle both. Now from outer circles we have to draw vertical lines. And from inner circles we have to draw horizontal lines from point 1, point 2, point 4, point 5, point 6, point 7, point 9, point 10. So we will get here 12 different points P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11 and P12. Now join these points by French curve or freehand. So the requested curve will get here and dark it. This is ellipse by concentric circle method. Next is ellipse by rectangle method. With same dimension, if we want to draw ellipse with major axis 100 mm and minor axis 70 mm, it means that we have to draw a rectangle with length 100 mm and breadth 70 mm and divide them or divide that rectangle in 4 equal parts by drawing line segment AB at the center of breadth and line segment CD at the center of length. So we can divide here a rectangle in 4 equal parts. Now divide 35 mm of line segment which passes through A in 4 equal parts. Name them 1, 2, 3, 4. And line segment horizontal from A is also divided in 4 equal parts. 1, 2, 3, 4. Now join point 1, 2, 3, 4 vertical points 1, 2, 3, 4 with point D like this, and horizontal point 1, 2, 3 can be joined to C point and extend it up to line 1, 1D, line 1D. Draw another line segment from C which passes through horizontal second point and extend it up to 2D. Likewise, third point. So we'll get here P1, P2, P3, P4 and P5 points and join them by French curve or freehand. So we'll get here quarter ellipse. Now the same process we can do here in another smaller rectangular box. Same method 1, 2, 3, 4. Divide horizontal line segment in 1, 2, 3, 4. Join vertical 1, 2, 3, 4 point to D point and from horizontal 1, 2, 3, 4 point. Draw line segments from C point, extend it up to 1, 2 and 3. We'll get here P6, P7, P8 and P9 points. Join them by French curve or freehand. And the same method which we did here above, that we have to draw below rectangle. So we'll get here full ellipse by rectangle method. So next method to draw ellipse is oblong method. This oblong method is also known as parallelogram method because in this method we'll use parallelogram instead of rectangle. So let us see how can we draw ellipse by parallelogram method. So here again we have major axis dimension is 100 mm and minor axis dimension is 70 mm. But here we have to draw parallelogram with 75-degree angle. So we have to draw ellipse in this parallelogram. So first of all, draw a parallelogram whose length is 100 mm and breadth is 70 mm, and the angle between two lines 100 mm and 70 mm is 75-degree. So we draw here a parallelogram. Now same as in rectangle method, we have to divide this parallelogram in 4 equal parts. So line segment AB, draw line segment AB and line segment CD in midpoints of 100 mm line and 70 mm line. Now same method as we use in rectangle method, line segment vertical from point A is divided in 4 equal parts 1, 2, 3, 4, and horizontal line from point A is also divided in 4 equal parts 1, 2, 3, 4. Now draw or join one point in with D, 2 point with D, 3 point with D, and in horizontal C1, C2, C3. So here we got P1, P2, P3, P4 and P5 points. Now join them by French curve or freehand. And same method we have to do in another parallelograms as we did in rectangle method. So here we'll get P6, P7, P8, P9 points and join them. Same method we have to use in below parallelogram and we will get another points and we can join our ellipse and dark it. Next method to draw ellipse is arc of circle method. So as per name, we have to draw so many arcs to draw our ellipse. For that, let us consider our major axis dimensions and minor axis dimensions are 100 mm and 70 mm respectively. Now for the arc of circle method, we have to draw 100 mm major axis AB and 70 mm minor axis CD at the center of line segment AB. Now half of minor axis, that is 35 mm, we have to take a 35 mm and make two arcs from point C on line segment AB. So these 2 points defines our focus F1 and F2. Now make 4 points from F1 at 1 centimeter distance. So 1, 2, 3, 4. 4 points from F1 at 1 centimeter distance. Now take rounder and take a distance from point A to 1 point. So radius is A1 and center is F1. So at center F1, mark arc here. Now take distance B1, long radius in rounder, but take distance from B1 and center as a F2. Cut first one arc from center F2. So we'll get here a point. Same as take a radius in rounder as A2 and center as F1 and make an arc. Now take radius in rounder as B2 and center as F2 and make arc which cuts the before arc. We'll get another point. Same as take radius in rounder as A3 and center as F1. Draw arc from F1. Now take a distance in rounder as a radius as B3. Take a center and draw arc which cuts before arc. So we'll get third point. Same as take a distance from A to 4 in rounder as a radius and take a center F1 and draw arc. Again take a radius in rounder as distance of B and 4, distance from B and 4 and make a arc from center F2 which cuts the before arc. So we'll get fourth point. So here we got 4 points P1, P2, P3, P4. Same method we have to use on another side. We got 4 points P1, P2, P3, P4 and join them from A to C. Same method and same arcs we have to draw here on another side. We'll get P5, P6, P7, P8, P9, P10, P11, P12, P13, P14, P15, P16. Join them one by one to get our ellipse and dark it. So this is ellipse by arc of circle method. Now next method to draw ellipse is rhombus method. So here we have to draw a rhombus, but with same dimension, means major axis have 100 mm and minor axis have 70 mm. So first of all we have to draw a 100 mm line and a 70 mm line in center of that 100 mm line, and then we have to join a points like this. So here we prepare a rhombus. In this rhombus we have to mark all centers of the sides of rhombus. So mark all centers of sides of rhombus. Name them A, B, C, D. Now mark two vertical line points. Join below vertical line point with A and B, and above vertical line point with C and D. Now mark the intersection points and name them 1, 2, 3 and 4. Now take a radius as A1 and draw arc with center as A. Same as take a radius as 2C and draw arc from center as 2. Now take a radius on rounder as 3A and center as 3. Same as draw arc from point 4 and radius as 4B, center as 4. So here we'll get our ellipse, smooth curve ellipse by rhombus method. This method is generally used in orthographic and isometric projections. Next and last method to draw ellipse is directrix focus method. In this method, we have some directrix, means a line is given from a ellipse and a focus. So here we got a ratio of directrix focus method. So in this ratio of focus to directrix from ellipse, ratio is 2 by 3. So eccentricity, we can say that it is 2 by 3. So for that we have to draw a directrix AB line, vertical line here, and at the center we have to draw a horizontal line, and focus is 50 mm from the directrix. So draw a focus F at 50 mm distance. Now mark or divide this focus distance of focus from directrix in 5 equal parts and mark it in 2 by 3 ratio. So that is our vertex V of our ellipse. Now take a line from directrix is in always ratio of 30. So take a distance of 45 from directrix. So if we take our distance of line from directrix is 45, then mark two radii of 30 mm from focus on that line on both the sides, above and below. Likewise, take a line from directrix is 60, then make a arc from center F as a 40. So make a two arcs above and below from center F or focus F. Now make a line 75 mm from directrix. So distance from focus is 50 mm. So mark from F above and below 2 points. So these are our points of ellipse. Join them with V point. 1, 2, 3, 4, 5, 6. Join them with V point. So this is our half ellipse. So this method is called directrix focus method to get ellipse.